All right, we're going to take a look at the Scratch interface here and how it's going to interface to the robot, and we're going to do some beginning commands that you guys are going to need to know about if you're going to help the other students that are involved with the robotics program coming up. So hopefully you were able to install BYOB on your computer, and you're going to want to go and find that file that I also included for download called Arduino Simulator. Arduino Simulator. Now, what does Arduino mean? Well, that's just the name for this type of brain board. So when I say the word Arduino, that means we're talking about the brain board. So what the program is going to do, it's going to simulate the brain board. And you can see when it does open up here that we've got a graphical depiction of the brain board. This is kind of what the Arduino brain board on the robot looks like. We've got some other things here too. We've got some LEDs. There's 8 LEDs, and these things are motors. There's 2 continuous rotation servo motors. You should recognize that term from Fondy Heat last year. And there's 2 positional servo motors. In other words, servo motors that don't go around the whole way. They'll just go to a certain position and stop. You should remember that from last year as well. Now, for some reason, when I opened this up, it went to my script. Scratch went to my script for the left motor. You don't really need to worry about that so much. Now, maybe take a minute to refamiliarize yourself with the Scratch interface, or if you've never used it before, take a look at it. There's a number of different what they call panes. These are different window panes that are part of the Scratch interface. Over here, we've got our controls selector. Down here, we've got our actual commands. So these may be more like command selectors, and these are the commands. In the middle here, that's where we put our scripts, and we can do things like import sounds and make our costumes here on the stage look a little bit different. We won't be doing a lot with costumes with the robotics because in our case, the robot is the actual costume, but we might venture into costumes a little bit, and we're certainly going to be doing things with sounds a little bit later on. Not today, but a little bit later on. All right, over here we've got our stage area. This is what the end user sees. The end user is not going to see your scripts and so forth. So if you were writing a game, this would be the stage. Basically what I did to do this program is I wrote a game program that would simulate a robot. It's going to simulate all these different LEDs. It's going to simulate these 4 motors as well. And we got a picture of the brain board just to kind of get people thinking about how this thing works. Down here, we've got our sprites area, and you can see that each of the elements up there on the stage is its own individual sprite. We're only going to worry about, for today anyway, the brain board sprite. So go ahead and click on the brain board sprite. Now, here on our commands selector, I'm going to click on motion and go way down to the bottom, and I'm going to see 2 custom blocks that were created for motion. One says left motor value 90, the other says stop motor, and right now that's on left motor. Okay, so you can guess that those are the commands we're going to use to operate our motors. And we'll get back to that in just a minute here, but let's also click on the commands for looks and go all the way down to the bottom. And there we can see we've got an analog LED number and value, and we've got digital LED number and value. I need to modify this block so it's got a default number. It doesn't have a default number in it right now. It will down the road. But let's not worry about that. Let's pull one of these digital LED command blocks out to our script area. Now, our goal here is to either turn on or turn off one of the LEDs over here on the stage. And let's just choose LED 2. And right now, LED 2 is on because it's a dark red. That means it's on. So we're going to try to turn off LED 2. So we're going to fill in the LED number with 2, give it a value of 0. Now remember that from last year? 0 is off, 1 is on. So if I was to double click this now, you'll see that LED 2 turns off. Let's turn it back on by sending it a 1. So same deal. So off, on, real simple. And this is a lot like we were doing in JAL last year. We're turning LEDs off and on, only we've got a much simpler interface. So let's pull out another digital LED command block, and let's go over here to control. And that's where we're going to find our timers. So let's turn digital LED 2 off, wait 1 second, and then, turn digital LED 2 back on. So off and then back on. Let's wait another second and repeat itself. How about we pull out this repeat loop and we drag that around that stack of blocks. This should repeat itself 10 times now when I double click on this. And let's watch. It's doing exactly what we expected. Now this is a lot like the for loop we learned about last year. I think we said something like 4, 10, and then LED 2 on, LED 2 off kind of thing. Well, this is the same thing, only it's much easier to see, much easier to understand with the graphical representation that's part of Scratch and BYOB. All right, so hopefully you get the hang of how to do this now. We can do this with any of our LEDs. Let's say we want to do 5. Let's turn off LED 5, and let's double click that, and you can see that that turns off. So what I'd suggest you do is set up some of these blocks and do a little light show like we were doing last year. Turn the LEDs on and off in a certain sequence so you get used to doing that. All right, now let's go back to our looks commands and down at the bottom. This is something a little bit different than we experienced last year with our JAL programming. Analog LED, number blank, and then a value. Here's how I like to explain the difference between digital and analog. Think about a digital light as being a light that's wired to a regular light switch that we can turn on and we can turn off. There's no in between. There's only on and there's only off. Think about an analog LED as a light that's wired to a dimmer switch on the wall. Okay? So we have all different values of dimness and brightness depending on what position we position the dimmer lever or the dimmer knob, depending on what kind of dimmer you have. So this is really cool because we can make our LEDs go to certain brightnesses. It can be all the way bright or just barely bright at all, which is really neat. So this is a number that is an 8-bit number. I think we talked about this last year, where there is 256 different values that you can set up for an 8-bit number. It's like maybe a stack of 8 different switches. We talked about a microcontroller or a computer is actually just a series of a whole bunch of switches. Well, here we've got 8 switches, and depending on how we arrange those switches on and off, we can get a certain number representation from that 8 bits or 8 switches. All right, and we have 256 different representations. If we use the number 0, we can only go to 255, if that makes sense. Suffice to say that 255 is all the way on, so I'm going to double click that, and you can see it turns our LED all the way on. And for now, as dim as it can go is going to be a 1. And I'm going to double click that, and it goes away. Let's go with something right in between, like 127. And double click that, and you can see it's on about halfway. So that's really neat. We can turn on and off our LEDs to certain values with our analog. Now, one thing about analog, let's look over here on our stage. LED 2, 3, and 4 don't have this little squiggly thing before it. That's because they are only digital LEDs. They can't do analog like 5, 6, 9, 10, and 11. So you're only going to be able to do analog LEDs on 5, 6, 9, 10, and 11. Let's try switching analog LED 11 to about half value, and there it goes. So kind of neat. That's a really neat feature we've got. All right, so I'd suggest you take these LEDs, use some analog values, use some digital values, set up a little light show with them, and it'll be a really good experience for you in using Scratch, and Scratch as a robot programmer. All right, so to get rid of these blocks, we're going to talk about motors now. To get rid of the blocks, you just drag them over, and anywhere here in the command area, that deletes them. And I'm going to go over here to my motion blocks, and again, down at the bottom. And I'm going to pull out a left motor value, and we're going to pull out a stop motor block as well. Now, with an Arduino, this is a little bit different. With an Arduino, servo motors go from 0 to 180. So 0 is turning one direction, full blast. 180 is turning the other direction, full blast. And 90 is in the middle. Maybe remember this from some of our VEX experience back when. There was a number right in the middle where the VEX stopped, and then all the way to one side was a certain number, all the way to the other side was a certain number. So these are really, really similar. So if I was to send the left motor a value of 90 right now, let's go ahead and do that. Well, it doesn't move at all. But let's send it a value of 91. Let's try that. And we can see, well, it begins to turn really, really slowly in a certain direction. So we're on one side of 90. Let's go to the other side of 90. Let's send it an 89, see what happens. There it goes, turning really, really slowly in the other direction. Let's go to a number 0 all the way to one side, all the way to one direction. You can see it turns very quickly in one direction. And let's go all the way the other way and give it a 180. And you can see it turns very quickly in the other direction. And let's give it kind of a medium number, like let's say 130, something a little more sensible. And we can see our motor is turning one direction quite nicely. And let's go to a number below 90, let's say 50 or so. And we can see it's turning quite nicely in the other direction. And let's say we want to stop the motor. Well, there's a couple of ways we can do that. We can push this stop motor, left motor command, which is what we're going to have to do on the actual robot. That's why I included it here in the simulator. Or you can actually just set that to 90, and that will stop the motor as well. So let's say we want to drive forward with our robot. Well, we know that we need to make our continuous rotation servo motors go in a certain direction. And let's say the way that my robot is set up right now, both the motors need to turn in the same direction. So I'm going to right-click this, and this is a really cool feature of Scratch, is I can duplicate this and just connect it right down below, and instead of left motor, I'm going to turn on right motor at a certain value. And let's make it that 50 again too. So let's turn on both motors at a certain value. So now when I double click this stack of blocks, both of my motors start turning at the same speed in the same direction. Now hopefully we're going forward. So that's how we would make our robot go forward. Let's pull out another stop motor block here, and let's put a right motor stop in that, and we can stop both of our motors at the same time now by clicking on that. All right, so this is really simple. So think about that. Let's say we needed to drive forward for a second, stop for a second, and then drive backwards for a second. Well, you should be able to jump right into this. Let's go over to control. Let's say that's one of our missions where we have to do that. So we're going to pull out a wait. So here we start our motor, and we're going forward. We're going to wait 1 second, and then we're going to stop. And let's pull out another wait 1 second. And let's go back to motion here, and we're going to go the other direction. We need to back up, okay? So that's going to be a number above 90 in this case. And let's make it that 130 for the left motor. Let's duplicate this block again, and 130 for our right motor as well. Okay, so let's say this is a mission. We're going to go out for a second, stop for a second, and then back up for 1 second, and then I guess we have to stop, right? We need to think this all the way through. So let's back up for a second, and look at this. We're going to right-click on this, duplicate this whole thing. Look, we get that whole stack. We'll dispose of that bottom part of the stack, and we're going to stop left motor and stop right motor. Now, when I double-click on this stack of commands, we should go forward for a second, stop for a second, go backwards for a second, and then stop. Beautiful, huh? Easy to write these scripts, easy to write a mission for what we've got coming up in robotics. Now, real quick, let's go ahead and talk about the other types of motors. There's the servo motors. We've got here servo motor 1 and servo motor 2. Those are positional servo motors. So we're going to put in here servo 1. And let's say that's an arm on our robot that goes up and down, and we want to move that arm to a certain position. So now I've got servo 1, and I'm going to leave my value of 90 in there, and I'm going to double click that, and you can see it turned and it went to a specific spot. And again, this is between 0 and 180. So let's go to 60 and see where that goes. Well, that goes to a different spot. And let's go back to 90, and it's going to go back to the same spot it was at before. So you can do that with servo 1, duplicate, and you can also do it with servo 2. Same thing. That one must already be at 90. Let's go ahead and put a 60 in for servo 2. And you can see it moves to a certain position. So if I double-click this stack, both of our motors, they're in that position right now, will go to the positions that we suggest them to. So in your mind, I want you to think about certain missions you might be doing. Drive out for a second, stop, move your arms, so that's a servo 1 and servo 2, and do something, and then back up and come back to home base. I'd like you to write a couple of missions like that here in the Scratch interface. More lessons to come, but that's the basics of turning on and off our LEDs, both digital and analog, and operating our motors, both continuous rotation and positional servos. Thanks a lot. We'll talk to you later.